Period. Okay. So today we are going to factor by grouping. Okay. So take a look at the examples that are on this page. What is the difference between the factoring we did for the past couple of days versus the problems we have today?
There's multiple.
We have 4 terms. So factoring by grouping means we have 4 terms. Okay. So I'm going to talk you through the steps, and then we're going to do 4 examples. Okay. That's it. I told you, short, sweet, and to the point today. So your first step when you have 4 terms is I need you to split into 2 binomials. Split into 2 binomials. What's big words? Split into 2 binomials.
Binomials.
It's
2 terms. Binomial.
What is
2 terms. 2 terms. So if you need to put this beside it, this is 2 terms. Okay. I'm wondering why there are individual conversations going on while I'm trying to teach. Stop. Focus. So our first job is to split it into 2 binomials. Your second job then, factor GCF of both binomials. Factor out GCF of both binomials. What's GCF again? Thank you. You need that today. Yes. You fine. Okay. Oh. I guess, yeah, we didn't make you one because we knew you were coming. Sorry. All right. So, your GCF becomes one part of your answer. Yes.
Kathy's baby.
Okay.
At least get these.
Kathy, I'm gonna miss you.
She all right.
He's almost
They're struggling.
They don't know. I swear, it sounds like.
Harley, you got first lunch.
Every other day.
Okay. GCF becomes one part of your answer. Binomial they share.
Hello?
Yes.
Is this Miss Rector?
No. Binomial they share in common.
This is not Miss Rector.
I think the intercom system's messing up on them.
No, they just look. No, earlier it sounded like a rat. Earlier.
Right. It sounds like a bomb was going off in lights, man.
Okay. So, you ready for this? We're ready for this. All right. Example 1. Here it goes. I'm going to blow it up. Blow it up. Whoop, whoop. Okay. So, I have 4 terms. I need to create 2 binomials out of these terms. So, the way you do that is you go parentheses, parentheses.
Whoa.
Woo! 2 binomials.
gosh.
Binomial 1, binomial 2. Okay. Looking at the 2 terms in binomial 1, what is the greatest common factor I can pull out? 4x squared. Oh,
Let me be great. I can't.
Shadow Dreams.
Oh, don't call my man a fake.
You had it. You had it today. You had it
I
today.
started this one.
Harley, you had first one today.
Okay.
Oh.
No, come here.
Okay. 4x squared. When I divide out 4x squared, what does that leave me with? 2x
That's it.
plus 1. Remember, when you really testing my patience today. Woo. Okay. When you divide out the same exact thing that is there, remember there is always an unwritten 1. Don't assume that it goes away. 4 divided by 4 is 1. Okay? So you're left with 2x plus 1. Take a look at your second binomial. What do they share in common? 5. Okay. What is left when I divide out 5? 2x plus 1. Okay. So
How are you getting 2x?
10 divided by 5 is 2.
Because you have to find the greatest common factor. And then when you find the greatest common factor, you find what can go into it.
Yeah.
So if you didn't have that plus there, with the 5, would you multiply the 5 to that side too?
Yes.
If it wasn't a plus.
Yes.
But how about the 4x squared? To multiply both of them twice?
The 4x squared would multiply into the first one, and your 5 multiplies into the second one. But if that plus wasn't there, then the 5 and the 4x squared would multiply into both. Okay.
Hey, bro.
Okay. Notice when you did this, they share a binomial in common. These should match. If they don't, something went wrong. Okay. These should always match. So the first part of your answer, I need a different color. The first part of your answer you get from your GCFs that you pull out. So your first part of your answer is 4x squared plus 5. The second part of your answer is what they share in common. 2x plus 1. That's it.
Don't say it's too easy, then you put some big numbers in there.
Oh, God. Then you stuck.
But at least we know that they always have to equal.
Okay, now, if they asked you to solve this, solving means I take both of these and set them equal to 0. So if they ask you to solve, you would set 4x squared plus 5 equal to 0. You would subtract 5 from both sides. You get 4x squared equals negative 5. You would divide both sides by 4, and you get x squared equals negative 5/4. How do I get rid of a square then?
You have to divide.
X squared.
What's the opposite of squaring something? Square root. So you would square root both sides and get an answer for x. Okay. So just be careful whether they say factor. If they want you to factor, this is what you're going for. If they want you to solve by factoring, not only do you have to factor, you then have to set each factor equal to 0 and actually solve. Okay. Yes, sir.
Is it square root button on this calculator?
Yes, sir. Second, and then your square button.
Oh, I see. I see.
So I have a question. Would you have to do both of those?
Yes, you would have to do both.
Set them both equal to 0.
Okay, let's move over to example 2. We're only worried about factoring right now. We're not worried about solving. But that's the difference between the two. If they ask you to solve by factoring, Not only do you have to factor, you have to set them equal to 0 and solve.
Is it
Okay.
just x squared that you need to?
No, you would have to do both.
So
So you'd have to do, so you would also have to do the 2x plus 1.
No, I know that, but it says x, so would I have to square it to get?
You would have to get your answer from there. You can't take the square root of a negative, so that's actually non-existent.
Oh. Oh, but if the x isn't squared,
If the x isn't squared, you're just done.
okay.
Okay, example 2. When I place these into binomials. Okay, I heard somebody say I can pull out an 11x squared. Okay, when I divide by 11x squared, my first term becomes 10x. My second term becomes plus 7. Okay, take a look at the second piece. What can I divide out?
12.
No.
You can't do 12.
Negative 6. They both share a negative, so I can divide out a negative 6. Divide by that negative 6, and I get 10x plus 7. Remember, that turns into a plus, because when I do negative divided by a negative, it turns it into a positive, okay, each time. So negative 60 divided by negative 6 is positive 10. Negative 42 divided by negative 6 is positive 7. So your final answer then, 11x squared minus 6, 10x plus 7. Okay, scoochie on down to example 3.
9.
Scoochie.
You can do 9x squared, right?
Okay, so Jackie says I can do 9x squared. I agree. When I do 9x squared, my bad, you couldn't see that. 9x squared leaves me with 3x plus 1. You said negative 8 out of the second one, which leaves me with 3x plus 1. So we end up with 9x squared minus 8 is my first piece. 3x plus 1 as my second piece.
Is there a way to find out that you're right? Like if you
Multiply that back through, absolutely.
I have this a lot.
Okay, so Elijah just asked, is there a way to figure out if I'm correct? Absolutely. We FOIL method it back through. So you would take 9x squared times 3x, which is 27x to the third. We're checking it to make sure that it is correct. So we need to FOIL, which means your first terms, so 9x squared and 3x. Your outside terms, which is 9x squared and 1, which gives you 9x squared. Your inner terms, which is negative 8 and 3x, which is negative 24x. And your last terms, which is negative 8 times 1, is minus 8. If that matches your beginning, you're good. So it matches your original problem, so you know you factored it correctly. Okay? Okay, last one.
4.
Okay, you said 4x squared, which leaves me with 2x plus 3. And you said 5. 2x plus 3. So 4x squared plus 5 and 2x plus 3.
That was.
Yes.
Will it ever be a case where it's not the same for those?
If it's not the same,
If it
it's
doesn't
wrong.
show up the same, it's not factorable.
It's not right.
Okay, I want you to glue this in on page 78. Leave yourself a little bit of room at the bottom. I want to do one more example with you. Oh, Jesus.
I should be like 100.
What?
78
I need to make sure it works first, though.
Hey, can I like hold this right there and then like?
Yeah, that's fine too.
You said what number?
That's what that is.
78.
I just burned it.
Okay, so like.
Yeah.
I mean, I know it's something like getting out.
I know how to do it, but I can't because of my nails. I know you come with it, if not, I'll just make it. Yeah, like I know, but like I can't, cause. Yeah, I'm gonna like slide it out and then. But it's up to you if you're comfortable with it. It's weird. Yeah, it is weird. Like,
He was thinking about it.
yeah, my mom had to do it. The doctor had to do it. It was kind of ridiculous. Ain't no fuck me like that. Leave 3 lines underneath. Or on top. Or.
It doesn't matter as long as you have room for this last example. I don't care where you put it as long as you have room for it.
Can I fold it like Jackie did?
Sure. I don't care. Okay. She is. She's a creeper.
I think I am a little bit, Jackie.
Little creeper. All right. So this is the last example I want to do with you. Because sometimes when you factor by grouping, you haven't gone far enough. You're not done factoring. It just so happened that every example on this piece of paper, you were done. Okay. This one, you're not going to be done. We're going to have to factor again. Oh, Jesus. Here we go. All right. So, factor by grouping first. What can I pull out of the first piece? X squared. And I'm left with x plus 2. What can I factor out of the second piece? Negative 4. And I'm left with x plus 2. We go with that piece. Okay, so normally we say x squared minus 4, x plus 2, and I'm done. Okay. This one that has x squared can still be factored. This is your difference of 2 squares. Okay. So sometimes your x squared can still be factored. So you can revert back to the box method. Okay. Or you can revert if you remember what I taught you with the difference of 2 squares. So should we just stick with the box method?
Yeah.
Yes.
Okay. Because the first part can still be factored. So I can put this into the box, which means x squared goes here, negative 4 goes here. Okay, when I multiply those two, I get negative 4x squared. What's my factors of 4?
1, 2, and 4. Negative 4. Positive 1.
So negative 4, positive 1, negative 1, positive 4,
Negative 2.
negative 2, positive 2. Remember, my b value that I always try to add together to get is non-existent, which means it should be
Equal to
0.
0.
So which one of these factors gives me 0?
Negative 2 and 2.
Negative 2 and 2. So I need a negative 2x and a positive 2x.
Just assume that they both like assume that it's x plus 2.
Because negative 2 and positive 2 give you 0.
I'm talking about, you know how the other one is x plus 2? Can you just assume that side is equals to?
As much as I'd love to say that, no. Okay. So when I pull out here, these share an x in common. These share a 2 in common. These ones share an x in common and a -2 in common. So your final answer then is x plus 2, x minus 2, and then another x plus 2.
So that's why you can't assume.
What?
Okay, so hold on. Okay, so this dropped down because we already had that. These came from when I factored here.
Oh, okay.
Did that just click?
Oh,
Okay.
Open up the word.
Okay, so this usually only happens when your x squared one becomes a difference of 2 squares. Okay, remember, in order to identify a difference of 2 squares, can I take the square root of x squared? What's the square root of x squared? X. What's the square root of 4? 2. That's where this came from and this came from. And then you need 1 plus and 1 minus.
Oh, yeah.
Hey.
but we can do that like by ourselves. We don't have to do the box method.
Yeah, you don't even have to do the box method. So, like, I could give you something like 16x squared minus 64. What's the square root of 16x squared? 4x, because the square root of x squared is x. What's the square root of 64? 8. We need 1 plus. We need 1 minus.
That's cool.
It works every time. As long as you can take the square of this and the square of this, and there's a negative in between.
Oh,
It works
but how about
every
if it's
time.
positive?
If it's a positive, it's not factorable. Like if I change this to a plus, you can't factor that.
You just can't.
You just can't.
See, I don't like that. That's wrong. You just can't. That's like, there's like no reason.
That's like a mom. Like,
I mean, okay, so normally if I would do this box method wise, okay, I guess I could show you why it doesn't work. So 16x squared and 64. What do you get when you multiply 16 and 64? I'm gonna need that number, friend. Multiply 16 and 64.
Hey Siri. Hey Siri.
Are you really asking Siri what 16 times
1,000
16?
times 64.
I did all this here.
Oh, I gotta
I
do
did
that.
it. I just been.
All right.
That's crazy.
So
Siri do this.
16 times 64 gives us 1,024. So remember, to show your factors, you can go here to y equals and divide by x. Okay. In order for this to work, to get a 0, I need to have exactly the 2 same numbers, right? I need a -2, +2, -12, +12 to get a 0. So when I go here to look for my factors, I got 1 and 1,024, 2 and 512, 4 and 256, 8 and 128, 16 and 64, 32 and 32. Don't tell me I got an example that actually works. Oh, no, it's not going to work. Okay, remember, this is a positive. This is a positive, right? So when I do my factors, in order to multiply to get a positive, I need positive 32 and positive 32, or negative 32 and negative 32. You don't get one positive, one negative to cancel out and give you 0. So you either end up, I need a positive 64 in there or a negative 64 in there. That's why it doesn't work. Because you can't multiply a negative and a positive to get a positive number for it to cancel out and give you a 0. Does that make sense now?
You said you can't multiply a negative number and a negative number.
You can't multiply a negative and a positive. In order for me to get a 0, I need a negative 32 and a positive 32, and that'll give me 0. But when I multiply these two, I should have a negative 1,024 that I don't have. That's why it doesn't work with a plus. Okay.
Now I like math.
Now you like Matthew?